Hi there, this is a question from the 2017 Exam 1. This is from the Matrices section and it is question 7. So this question, before we even start, it has a lot of information provided. It's written really long, a lot of words. To some it may seem really overwhelming, but what you need to do is just really identify what the question's trying to ask when you first read it and identify any keywords in there that may help you along. So we have a fish farm, we have young fish Y that grow to juveniles J, or they may die D. We have juveniles that may eventually turn into adults A, or they may die, and we have adults A who eventually will die. The initial state matrix of F0 is shown below. So this is what we start with. We have 50,000 who are young, 10,000 juveniles, 7,000 adults, and 0 that are dead. Every month, fish are either sold or bought so that the number of young juvenile and adult fish in the farm remains constant. So that sentence there is the key sentence out of all this information that will help us guide us to the correct answer. So it's saying every month fish are either sold or bought and that remains constant. So what we need to do is at the end of each time we're calculating a new population from the initial state population, that it ends up getting back to this F0 value. So remains constant. These numbers, we're either going to have to add or subtract numbers to get back to this. So the population of the fish in the fish farm after n months can be determined by this recurrence equation. Or recurrence rule, sorry. So we've got a matrix here, and if we multiply it by Fn and we plus a B matrix, it will give us the value of what the population is after a certain nth month. So where B is the column matrix that is shown the number of young, juvenile, and adult fish bought or sold each month, the number of dead fish that are removed, and the number of dead fish removed. Each month, the fish farm will. We've got a couple of different scenarios here. We need to find which one of these is correct. So the first thing that I think we should do is work out what the value of F1 will be if we did not sell or did not buy any more fish, which is the matrix B. So let's put into our CAS calculator this matrix and the initial state matrix of F0. So if we multiply these together, so let's get out a CAS calculator. We've got our matrix there, we've got our initial state matrix, and if we find out this answer, if we weren't to change this by matrix B, which is adding or subtracting fish in the matrix, we would have this matrix value. So if we write this matrix value down over here, we would have 32,500, we would have 20,000, we would have 8,650, and 5,850 here. Okay, so this matrix is if we did not change anything using the matrix B. So there's our young, our juvenile, our adults, and the deaths. But remember, in this sentence, it said that the young, juvenile, adult, and the deaths all remained constant. So we need this matrix to equal the F0 matrix. Okay, we need this matrix here to equal this matrix. And the difference that we can do here is for the young, we would need to plus 17,500. So we'd need to add 17,500 to get it to 50,000. The juveniles, we would need to subtract 10,000 to get it from 20,000 to 10,000. For the adults, we would need to subtract 1,650 because it's 8,650. We need to get to the constant amount of 7,000. And for the deaths, we would need to subtract 5,850 once again to get it to the constant amount of F0 there. So now since we've done this calculation, let's have a look at which one of these is true. So for each month, the fish farm will, A, is sell 1,650 adult fish. So let's have a look, adult fish here. We need to remove 1,650 from our population. And how we do that is we sell it. So that one is correct. What we could do is go through the rest of them and double check them. So let's just pick one for example. We sell 17,500 young fish. Actually, from our calculations, we need to purchase 17,500 because we need to get it to 50,000. So that one's wrong. And you could go through if you had time and check all of those, but luckily for us, A is the answer. So we need to sell 1,650, my apologies, to get it back to our original 7,000. So let's have a look at the assessor's comments for this one. Let's find the matrices section. So here we go. Question number 7. Answer is A. Only 36% of the cohort managed to get this one correct. So hopefully that helps you a bit with the matrices and when we've got a part B in the matrix, in our recurrence rule, how we could calculate what that part B is. The key word, as we said in here, is it remains constant. So we could calculate it as we did on our CAS, get to a value, and then we have to get it back to constant so we can adjust these values in a B matrix to make sure that our answer gets back to the F0. Hopefully this one helps.